join the club and design and build my own version. I started planning this thing in Fusion 360 last year. That's the software I'm using here, and right now you're seeing a quick rundown of that design process. So the idea was to kind of give myself a challenge and go all out on this thing. So the goal wasn't to make this fast or easy to build, but to basically overbuild and maybe even overcomplicate things a bit, because for me it's just more interesting to make that way, and it also means I can potentially learn more things along the way. I tried to include pretty much every feature and adjustment that I thought might be useful to me in terms of functionality, but I also made some design decisions just based on what I thought would be interesting to make, or even just for looks. This type of machine is most often used by people who make knives, but that's actually not my focus here. I'm not really into knives. I mostly need this for general metalwork, and that's why I chose to use a wider belt than the common 2x72 inch size. So this is technically closer to a 3x72 inch grinder, or to be accurate 75 by 2000 millimeters, because I'm not from the US, so my belts are metric, and also inches give me nightmares anyway. And yes, I made plans for this again, and the CAD model you're seeing here is also included, so if you're interested in that, just click up here or check the description. This build was pretty complex and it took a long time to complete, so in order to keep this video somewhat reasonable in length, I'm going to split this into 3 parts, and I'm going to give you more info about all the stuff you're seeing here as I'm building it. So for now, let's just jump into the actual build and start making the first part. And that would be the main plate here, which is the biggest part and also the one that took the longest to make. I started out with this big steel plate. This is just basic hot rolled steel because it's cheap and I'm cheap. I bought this large enough so I could make 3 big parts out of it. So I had to cut this into 3 pieces, and unfortunately it's way too big for my bandsaw and too thick for the plasma cutter. So I had to use my angle grinder, which took ages and wasn't very enjoyable. Now I can take this over to the mill and face that rough edge that I just cut to create my first clean reference surface. And I drew on the rough shape with a marker there, just so I can see what's what and keep myself from making any dumb mistakes. Now that I have one side that is flat and straight, I can flip the part over and face the opposite edge, and that way I got 2 edges that are straight and parallel, which is a good start for measuring things. This piece is now small enough to fit into the bandsaw, which helps cutting out this chunk on top here. Right now I'm just kind of roughing out the outside shape, but all of these edges are going to be machined eventually. Now the part goes back into the mill and I can clean up the cuts I just made. The narrow section of the part now fits into the vise, which helps me to clean up some of the remaining edges. And technically it's not necessary to mill down every edge, but I do need some of them as a reference for measuring, and I also just want everything to have a uniform flat machine surface in the end, and not a mix of saw cut and machined edges. I'm cutting a slot in there now, which is going to help me to remove this piece on top there. And while I'm at it, I'm drilling a center hole that will be the reference to create the large circle at the round edge and the back. This cutter has a 45-degree angle, which helps me to clean up these diagonal edges. Doing some finishing with the file, and now everything goes on the rotary table to create the round shapes. And I'm getting a little creative here to mount this onto the chuck because I'm usually too lazy to take that off and attach things directly to the table. But it also has the advantage that I don't need to remove my vise. So I can now spin this around, and now I'm side milling the outside edge. I was kind of afraid to overshoot this cut on the bandsaw, so there's a lot of material left to remove here, which is why I'm using my power drill to help me out a bit. To remove this circle, I'm cutting a slot again, but if I cut this all the way through, then at the very end the outside part would just drop down, which is pretty risky. You don't want to risk parts coming loose on the mill. So my solution is to leave just two little tabs all the way at the bottom that are strong enough to keep this in one piece, but small enough to be easily removed. Now the part is much easier to hold because I can just grab it from the inside using the chuck. And now I'm drilling and countersinking the mounting holes for the motor. It's time to drill all of those other holes now. Obviously these need to be perfectly positioned if I want everything to fit together, and I'm doing all the positioning using the digital readout on my mill, so that's why you're not seeing any scribe lines or center punch marks. I did, however, double check everything with a caliper before drilling, because the more time you put into a part like this, the more paranoid you get. And to make sure these holes are accurate, you would also normally spot drill them first. But this is a split point drill, which means it has a self-centering feature, and that saves me a little bit of work here. Most of these are also countersunk to hide the screw heads, and in this case there's a reason for that besides optics. The side of the machine needs to be flat because the lever for the belt tension mechanism is going to sit there, and it would otherwise collide with the screw heads if they were sticking out. I'm now cleaning up the cutout for the motor using a boring head. I cut this radius a little smaller on purpose because I was kind of expecting that cut to come out looking as bad as